Hello and welcome to Cognito Key. We're surrounded by these massive power lines stretching across the landscape, powering our entire lives. But have you ever stopped to look closely at them? There's a really curious detail you might have missed.
Yeah, they always have that gentle curve to them, don't they? They're never pulled perfectly tight like a guitar string. So, why is that? Is it a mistake? Well, not at all. That dip is actually a supercritical piece of engineering.
In the world of electrical engineering, this droop has a specific name. It's called sag. And believe me, understanding it is absolutely essential for keeping our power grid safe and working reliably.
So what exactly is sag? Well, it's pretty simple. It's just the vertical drop from where the wire attaches to the tower down to its lowest hanging point. And that horizontal distance between the two towers, we call that the span. Easy enough, right?
To make this super clear, just picture a clothesline in your backyard. If you pull it really tight, that's high tension. The sag is tiny. But if you let it hang a bit looser with low tension, the sag gets much bigger. So it's an inverse relationship. The more you pull, the less it sags.
Now, this little dance between sag and tension isn't just a fun physics fact. Oh no, it is a crucial balancing act that engineers have to get just right. It's all about public safety and making sure the lights stay on.
Let's think about the extremes. On one hand, what happens if you try to get rid of the sag by making the line super tight? Well, the tension could just get too high for the wire to handle. All that stress could cause the line to actually snap, which is obviously dangerous and means a power outage for everyone.
Okay, so what about the other extreme? What if you have way too much sag? Then the line hangs dangerously low. That reduces the safe distance, what we call ground clearance, between that high voltage wire and anything below it, whether that's people, cars, or even buildings. It's a huge safety hazard. So you see, it's all about finding that perfect sweet spot.
So, how in the world do engineers find that perfect balance? Well, they have to juggle several different variables that all affect how much a power line is going to sag. We're about to break down the 5 most important ones.
So, the big 5 are the weight of the wire itself, the span between the towers, the tension it's under, the force of the wind, and of course, the temperature outside. Let's dig into each one.
First up, the conductor's weight. This one's pretty straightforward. The heavier the wire, the more it's going to sag under its own weight. Makes sense, right? But here's a cool thing. That weight can change. In cold places, ice can build up on the lines, making them dramatically heavier and causing them to sag a lot more.
Second is the span, or the distance between the towers. Now this is where it gets interesting. The relationship isn't just 1-to-1. Sag is actually proportional to the square of the span's length. What that means is even a small increase in the distance between towers causes a much bigger increase in the sag.
Third, we have tension, which we've already talked about. We know it's that inverse relationship, more tension, less sag. But engineers have to be really careful here. Cranking up the tension to reduce sag puts a whole lot more stress on the support structures, like the insulators and the towers themselves.
Number 4 is wind. Wind is tricky because it doesn't just push down. It pushes the line sideways. This adds a whole new dimension to the problem. It causes the wire to swing out, and that increases the sag, but in a diagonal direction. You have to account for that to make sure the lines don't swing into each other.
And finally, we have temperature. Just like pretty much any metal, the conductor material expands when it gets hot and contracts when it gets cold. So on a burning hot summer day, the line actually gets longer and sags more. Then in the dead of winter, it shrinks, gets tighter, and sags less.
So with all these things constantly changing, ice, wind, heat, cold, how do engineers nail it every single time? They can't just eyeball it. They rely on some very precise and complex calculations to predict exactly how that wire will behave in any condition imaginable.
And what's really fascinating is that the math actually changes depending on the size of the span. For shorter spans, maybe up to 300 meters, they can use a simpler formula that treats the curve like a parabola. But for really long spans, like when they have to cross a huge river, the true shape is a catenary, and that requires much more complex math to get it right.
Okay, that was a lot of physics and engineering, I know. So let's just quickly boil it down to the most important things to remember. What are your key takeaways here?
First, sag is totally intentional. It's a design feature, not a flaw. Second, it's a critical balancing act where too much or too little is a real problem. Third, just remember those 5 key factors: weight, span, tension, wind, and temperature. And finally, all of this is carefully calculated by engineers to keep us safe and our power on.
So the next time you're out and you see a power line, I hope you look at it a little differently. That simple curve, it's not so simple after all. It's actually telling you a story about the weather, the distance, and the incredible, invisible engineering that keeps our world running.
If you learned something new today and this sparked your curiosity, please help our channel grow by subscribing to Cognito Key. And don't forget to hit that like button and share this with someone you think might find it interesting. Thanks so much for watching.